anything else. So with that, I'm going to bring Michael on and we can get rolling.
Hi, everybody. My name is Michael Fig. I'm a software engineer at Agoric. And this presentation is all about how to use the Agoric wallet in your Dapp, especially the APIs and the UI. So as Roland had mentioned, we do have a live chat, and you can always join our Discord later to talk more about things with our engineers. We're always listening on there. And the agenda for today's presentation is first going over the Dapp architecture. This is how dapps and the wallet are all connected. Then we'll have a little demo of the wallet. You've probably seen this a number of times and many of you have played with it, but this will just explain to you what's happening under the covers. And finally, we'll talk about the wallet API, how exactly your Dapp interacts with the wallet. So as far as Dapp architecture, you can think of the Agoric system as a bunch of interconnected Agoric VMs that some of them are on the blockchain, some of them are local. And then the wallet is the user's trusted agent for interacting with that network. Finally, dapps are basically web UIs that also interact with Agoric VMs, but they have their own agendas, and the user doesn't have to trust them in order to make sure that the dapps can't steal their money. The Agoric VM uses the swing-set kernel, which Brian will be talking about in an hour, to host secure JS object capabilities. So the Agoric VM specifically is secure JavaScript plus the use of a kernel. So this allows multiple independent entities within the kernel to run without being able to compromise one another. So it's another partitioning of how a VM is set up. So the Agoric chain is made up of validators that run on-chain Agoric VMs. So these validators are not regular clients. They're just backing the blockchain themselves. And the consensus between these validators is what causes the chain to accept or enact transactions in a certain way. But what we will be talking about mostly is the Ag Solo, which is an off-chain Agoric VM that can communicate with the chain. So Ag Solos are basically somebody's entry point into the Agoric system. They have their own user interface and they have their own way of speaking to chains, and not necessarily just one chain, but they can be multiple chains and multiple other network connections. So the wallet is the user's trusted agent that runs in the user's private Ag Solo. When you run Agoric Start, you start one of these Ag Solos with the wallet. So the wallet allows you to enable or disable inbound connections from dapps. And we'll get to that in a little bit. And importantly, it allows you to approve or decline proposals from enabled dapps. And these are Zoe offers that basically the Dapp says, I want to have the user offer something. And then the wallet pops up the message and the user can say, yes, I do want to enact that proposal, or else I just want to decline it. Finally, a major role of the user's agent is to manage pet names for different things. So a pet name is basically your own personal name for something. So my personal name for my mom might be Mom, but your personal name for my mom is not Mom, it's different. So a pet name is something that the user can assign to make sure that they're talking to the right person, and that if they've seen something before, then the wallet can describe it in terms of the pet name that the user gave it. So dapps being untrusted web UIs, they can be anywhere. Usually they're web apps on the internet that interact with your wallet through the Web3 APIs. They usually want your money. That's what dapps are. They want to help you exchange something, possibly not collecting anything on the side. They might want to give you something for free, but it's a dapp's main purpose is to do something with assets on the chain. And finally, you use the wallet to control what access they have and to manage the proposals. So this is a great diagram that Kate made up for an earlier talk that basically explains how these different parts fit together. So on the left here, we have the Dapp user interface. And basically that allows you to do something. The details are not so important, but the user interface can talk to the dapps app server, which is an Ag Solo running for that Dapp. So the app server, or also called the API server, is providing services to the user interface that are contacting on-chain assets. So the API server might actually make an invitation. The contract is running on-chain. So the API server can make an invitation, and then it can use the on-chain connection to send something to the wallet. Now, currently, this actually happens via the Dapp UI. The Dapp user interface is the one that proposes something to the wallet. But we hope to change it so that the API server on-chain can talk directly to the wallet in a secure fashion, so that the wallet only gives away certain access to it. Finally, the wallet makes an offer, and then the wallet's user interface tells Zoe to do something, and then Zoe does something. So the wallet is mainly a way of talking through Zoe to different contracts that the Dapp might be using as its backend. Okay, so I'll get to the wallet demo now. The important things is that the wallet is really just another Dapp, but what's special about it is that it's installed in the Ag Solos automatically when they start up. So it's possible to have different wallets. It is possible to specify installing a different wallet when you start your Ag Solo. But the important thing is to remember that just like other dapps, this Ag Solo is installed with its own backend. So I'll go back one to show you. So in this wallet side, this is the user's Ag Solo, but the app server running on the internet also has its own wallet that represents the Dapp. So these Ag Solos can run really anything, different kinds of dapps, different kinds of API services. And the chain really just runs contracts. So it doesn't have ways of installing APIs on chain. So the wallet Dapp that's installed automatically is part of the Agoric SDK. It's in packages Dapp Svelte wallet. This was a wallet based on Svelte that we cooked up in about a week. It has many shortcomings and many things that could be improved, but it was basically a proof of concept to say, this is a way that the user can interact with the funds on chain. The UI subdirectory is the web-based front end, and the API subdirectory is the backend for that front end. So when we talk about the wallet and dapps interacting with the wallet, we're really talking about what does the API server provide? Because the UI is only visible to the owner of the Ag Solo. The API is how other things interact with it. Okay, so now I'll just show you how this all works. Okay, so I'm following the instructions that in the Fungible Faucet that Kate demoed earlier on. I'm just going to start and reset the chain. So this is running a simulated chain attached to my Ag Solo. Oh, I did something wrong. 1 second, please. Yeah, minor technical difficulties. I'm using different node versions, so that got in my way there. Okay, so I'll just start up the simulator and the Ag Solo. Okay, so the simulator is basically started. So the fake chain is the simulator, and then this is the command to start the Ag Solo. It starts listening on the WebSocket that allows us to have a trusted path to it. And then it just initializes a bunch of things between the Ag Solo and the chain. These are accelerated round trips, just to show for testing. We hope to reduce the number of round trips in the end. Using a technique called promise pipelining, we can actually get this down to a much faster startup time. Okay, so this is showing you that the dapps felt wallet is being deployed to the AgSolo. And I'm just going to pull up the dapps felt wallet. So Agoric open tells your web browser to open up the trusted path. So here we see I've opened the REPL, which has a little command line at the bottom that we'll be using later. But this is the Agoric wallet. You'll notice it's running on port 8000. What's important is that the wallet has a special access token. So this access token is private to the user. This is so that other users of the machine who might have access to the wallet UI can't get to it. So if I were just to go to 127.0.0.1 without the access token, or I just change the access token a bit, then you'll see it'll come up with an empty wallet and it'll just complain. If I run it with just an empty access token, then it says you must open the Agoric wallet with the Agoric open REPL command line executable. Okay, so I've done that over there, and now here's the wallet. It has some little sections in the inbox saying that there are offers, incoming payments, and dapps. I'm going to now deploy the different parts of the I'm going to deploy the contract and the API server for the Agoric Faucet. So this just takes a couple seconds to run. It installs the Fungible Faucet. And what you'll notice here is that as it's doing the deployment, it's installing all the code on the AgSolo. In other cases, then in a real deployment, this would be on the AgSolo on the internet, but we're all running the same things locally, basically. Okay, so this is where pet names are in action. We have a mention that the Fungible Faucet is trying to talk to us over localhost 3000. That was the thing that I started earlier, right here. And the Fungible Faucet is telling you, yes, you need to approve it before it can be enabled. So I'm going to call this Kate's Faucet. Okay, so now Kate's Faucet is approved. And we say OK here. And you see that now the button is here to mint the fungible tokens. So on this part of the thing, you'll see on the wallet that Kate's Faucet.token is available. So Kate's Faucet is the name that I gave to it. It's the pet name. So I know her tokens as Kate's Faucet.token. That tells me where it came from so that later I can understand when two tokens are the same thing, when another website is talking about the same faucet token as Kate has. So I'm going to mint some tokens, and then it explains, please approve the offer. Now I have an offer up here. Kate wants to give me 1,000 Kate's Faucet tokens into that wallet purse. I can accept it. And then sure enough, now Kate's tokens appear. So that is the basic flow that Kate had explained earlier with how the Fungible Faucet works. Next thing I'm going to do is just show you what the WebSocket API looks like. We'll get into this more later, but essentially this DApp at localhost 3000 can't directly talk to localhost 8000. It has to first get a wallet bridge. So the bridge allows this DApp to have an iframe that I'll show you what that looks like. The DApp has an iframe right about will I find it? No, maybe I won't. We won't get into that. But if I turn on debug mode, then I can see all the messages that this DApp has sent. So the wallet has told us how to contact the wallet. We've sent to it some get purses requests and get the deposit Faucet ID and suggest an installation. These are all things that basically wire up the dApp to our wallet. This is how we wired up the token. So when I mint more tokens, you'll see here that the proposed offer came from Kate's Faucet.instance. That was actually proposed by the dApp by suggesting an instance called instance. So it was prefixed with Kate's Faucet, but this says that basically this registered name on the board, which is like a public bulletin board of well-known objects, corresponds to the instance that we want to suggest to the wallet. So all of these messages went out. Then we got back a whole bunch of things saying we need the dApp approval. So this was how Kate's dApp understood that we needed to first approve or enable the dApp in the wallet. This point here is where we actually did that. So I'm just going to go back up and then we'll show you how this all works again. I'm resetting things. Okay, that's all going. It's going to make its round trips pretty soon. Just uploading the code for the wallet. And there go all the initialization. And I'll have to deploy the contract again. So I'm going to run the same demo just with debug mode enabled so that you can see the messages flowing back and forth. Okay, so I'm just going to say OK to this. You'll notice that the Fungible tokens button is disabled because we haven't actually connected to the wallet yet. So I'll turn on debug mode and we'll see that, yes, we sent these messages. We wanted to get the purses, get the deposit Faucet where we can send invitations, suggest some installations and issuers. And it just came back with, we need dApp approval. So as soon as I go to this wallet and I enable the dApp, this time I'm just going to call it my Faucet. We'll see that more messages came. As soon as all these dApp approvals were reported, then the actual messages got forwarded to the wallet, and it came back with an update purses request or response. So the update purses tells your dApp what are the parameters around the purses that this wallet understands. So with different dApps, you might actually use this list of purses to decide, oh, I want to create an offer from a given purse. So all these parameters, just have a look at a dApp that you are interested in that can do something similar, like maybe the auto swap or the simple exchange. And then you can see that these update purses come in. The dApp exposes these as a UI elements where you can drop down a purse. And you'll see that the current balance of the purse is there. So the Zoe invite purse is empty. It just has an empty array. The fund budget Moolah purse has a value of 1900, and the testnet USD has a value of 20,000. And you can see here that the testnet USD has 3 decimal places. So these are all the purse reporting. And then we get back some other responses from our get deposit Faucet ID. We get a response that says the Faucet ID is this number in the board. We tell that we got the dApp approval, and then we return the things that we suggested. So we had suggested an installation of installation. So it tells us that this myFaucet.installation has been added. More update purses messages, but this was essentially the end of the relevant things for us. So what I'd like to show you next, well, first I'll go back to the wallet and show you more about pet names. So pet names in the wallet, we can go into setup, and you'll see that these are the different issuers we have. We should be able to assign different pet names, but currently we don't. We only have pet name assignment for dapps, but I can change this at any time. So you'll see that, let's call it Mosset. When I change that, you'll see that all of a sudden now it's Mosset.token. Mula, Simoleon, and Zoe invites were created by the Agoric chain when we initialized the egg solo by the sim chain. And contacts also appear. So when you import something, you give a board ID and you give it a pet name. So I can basically say, I want to create a contact to somebody I met at a conference or something, so I can send them tokens if I need to. So let's move on. The wallet API, I've kind of glossed this over a bit because it's fairly complex right now. But basically, the wallet bridge is a web page that has direct access to the wallet, and it essentially provides a facet for the Dapp. And a facet, as we've discussed earlier, is a subset of an API that's customized for a certain environment or a certain consumer. So the Dapp never gets to send messages directly to the wallet. It only gets to talk to something that knows where the Dapp is coming from, knows what the origin is. So the wallet bridge is available over post message from the Dapp. And another way of interacting with the wallet bridge is via, or the wallet itself is via the trusted REPL. So the REPL is the read eval print loop. This is the little command prompt that you see in the wallet. So if I go back to the wallet, I can see my home.wallet exists. And if I send it a message, it tells me all the methods that it has. This little shortcut of tilde is a different way of writing this, what you've probably seen before. But in the command line, the tilde is a bit of a shortcut instead of having to write E. So if I run that, they'll just get the same response. But now I'm going to start the REPL only. Okay, so with the home wallet, I can do something like home.wallet get issuers. So that's right here. And it tells me we have issuers for these different things. So we invite testnet USD, and these are things that the wallet uses, the wallet UI uses to display the information we were seeing earlier. So in here, we have all this list of issuers. They're all generated by getting the issuers list. We have the UI for the wallet is actually using E to contact a remote presence for the object. It uses a connection to the wallet that allows forwarding of objects. So another thing we can do is actually look at the offers that we have. We can decline or get them. Let's get the inbox JSON. Okay, where is this? Let's see what the inbox looks like. So it says currently the inbox is empty, but it had some updates. So if I run this again, mint some fungible tokens, then over here the inbox notifier will say that we have some data in our inbox. So I might want to say, let's get the value is a JSON object. So I'm going to say, let's take history 5. I'll JSON.parse history5.value. And then you see that this is a JSON object and it has various things in it. It has a proposal associated with an origin. It tells that our first pet name was mossit.token. This is where they're going to put the tokens into. The Dapp context is something that your Dapp can receive back. And then all these different details of the actual history. So what's important here too is that the proposal for display shows we want a certain token of mossit.token, and the display info says that it's just a natural amount math. So this is all kind of advanced stuff, but the bottom line is that the wallet just uses ERTP and Zoe offers, just like you could with your test contracts when you're writing it. So the wallet is a fairly sophisticated Dapp, but like I said before, it's just something that you can implement in terms of the underlying stuff. It's not really privileged in the system. It just provides a service to other dApps. So that's the REPL interaction. The last thing I wanted to talk about was remote object references. So we're kind of moving away from running JSON objects back and forth between the wallet and the iframe. We'd like to be able to actually send object references. This is what the wallet does internally, but currently not many dApps do. The ideal here is that if you have an object reference, then you can call methods on it, just as I did here with the E method, with the E proxy maker. So these methods are tunneled over the connection to the wallet and back. The wallet backend implements these methods like getInbox JSON notifier, and you use them the same as you would within your own contracts. So whenever you implement a method, you can send an e-message to it. And this takes care of the whole promise-based remote methods. Okay, that's about all for the API. I encourage you to look at the documentation for the hackathon, where we do have an intro, and we have some documents on the wallet API, like the actual backend APIs. But really, the main way of learning about the wallet is to look at a dApp that does something similar and try using it. We will have more documentation over time, and we hope to make this clear for everybody to understand. As should be very clearly said, we're still in an alpha release, and we're basically just trying to get things working. But we do have plans to improve our wallet support. There's a third party that's really interested in helping us with developing our wallet and perhaps making it as a plugin for their wallet, as well as other things where we can improve the user experience and the developer experience. Another innovation we have is that we want to, as I said, make it possible for an ag solo running for a dApp, an API server for a dApp, to communicate with the chain and have the dApp UI negotiate a rendezvous in between the dApp backend and the wallet backend. So that would allow even more direct programming with more clarity. Finally, the code for all this stuff is in the Agoric SDK. The dApp felt wallet that I pointed out before is in that SDK. And contract examples, I should replace this and say dApp examples are really important. Just go to the Agoric GitHub and search for dApps. I'll show you how that looks. So in the Agoric GitHub repository or GitHub organization, if you just search for dApps, you can see the different dApps we've built. So these are all things that you can have a look at and experiment with. The ones with a greater pulse are usually the ones that are used more often. Fungible Faucet only existed very recently. Dapp encouragement is one that's a little bit trickier, but explores more of how to interact with the wallet. Thank you for your time.
All right. Michael, thank you so much for coming in. We had one comment that we definitely need to put together a diagram to understand the various components of the wallet that are talking together, and I know that that's in the works. So stay tuned, everybody. We will have a diagram coming up. And